All right, so last week we did sort of an overview of immunity. We actually got to meet each other during a Zoom. This week we are actually going to now not do the big sort of huge introduction. We're going to get into some of the details of how our immune system works. Now, the first thing we're going to talk about is barriers. We have to remember that the goal of immune system is to eliminate pathogens. Pathogens are any organism that cause disease. And we focus on four main classes of these pathogens that we're trying to avoid, inhibit, get rid of, basically prevent them from making us sick: bacteria, viruses, fungi, and parasites. And we've talked a lot about how the immune system realizes when there's a problem using PAMPs as an example. Remember that PAMPs are pathogen-associated molecular patterns. They are molecules that are not on us, not on self, and are only associated with pathogens. PAMPs on those bacteria, viruses, fungi, parasites. Now, all of those pathogens will also have molecules that are shared with us. Those won't be considered PAMPs because those are self molecules, and we don't want to attack ourselves. So this is going to come up a lot during these three lectures, the idea that the innate immune system and the adaptive immune system overlap and talk to each other a lot. And it's not that just one functions in the first few hours and that adaptive immunity is doing nothing for the first part and then innate immunity turns off or anything like that. There's a ton of feedback. And so we try and divide the innate immune system and the adaptive immune system. But I just, again, want to say from the beginning, things will get complicated. Don't freak out if you're like, wait, I thought that was part of adaptive immunity. It probably is, but with the overlap and some blurred lines, and not the rapey blurred lines way, but blurred lines between some of the distinctions we make in the immune system. So, innate immunity. What does it mean to have something that is innate? Innate immunity for us is the first responders. Innate immunity is present at all times. And I'm going to sort of use the idea of sort of first responders versus specialists in a hospital. We have a problem here, we're thinking about immunity. You cannot call the hospital and say, hello, I'd like to speak to your best cardiothoracic surgeon in the middle of the night. Not there, not on duty, not sort of around all the time. Innate immunity is going to be always working and always keeping an eye out and always in pretty much all of the tissues. There's not really a place in our body that you can hide well from the innate immune system, at least for very long. It's there all the time and it's the first response. Again, just like if you were at your house and had some sort of emergency, calling 911, even if you do need a cardiothoracic surgeon, that's not the first person who's going to show up to your house. It's going to be those first responders, those more generalists who have a sense of a lot of different things, but aren't going to always be able to specialize and be quite as precise. And because they're not specialists, they can kind of distinguish and they will respond differently. They'll kind of say, hey, I think this is the virus, or I think this is the bacteria, but they won't say, okay, this is Streptococcus pneumonia, serotype 1-2. It's not going to be, there's not going to be cells or proteins that are directed to just one type of pathogen. It's going to be more generalist, just like, hey, I generally know what to do when you're bleeding. I'm not going in to, ablate certain neurons and do very specific surgeries. I'm generally going to be able to bring you back up or warn or sort of know at least who to pass you off to. All about quick, but general. And, there are many different ways you could think about it. I've used, calling 911 in the middle of the night. But one of the other ways when you want to think about protecting yourself, the immune system isn't that different than the way we would respond. And so generally think about what would you do if there was suddenly a zombie apocalypse? Well, first thing we probably do is shut ourselves inside. This is actually a huge part of the immune system. We have barriers. The fact that we have skin, we have hair, we have things that divide the outside from the inside prevent pathogens from being able to get in and often eliminate pathogens before they're a problem at all. If you think about it, when you tend to get hurt the most, you tend to get hurt when you have, or infections, sorry, you tend to get hurt the most when you have cuts, or if you've taken something in, whether that's air or food. It's only when it gets past those barriers, those initial barriers, that we really have a problem. So barriers are awesome, and they are so much better and more effective. And, best way to, we talked about how the immune system comes at a cost. We can save ourselves that money by not having an infection to start with. And when we think of innate immunity, we think of generally 3 categories of barriers: mechanical barriers, chemical barriers, and microbiological barriers. Our mechanical barriers are just the tight junctions in our skin, the fact that we can physically close our eyes. Fun story, my mother actually has a neuromuscular issue where she can't close one of her eyes completely. I can't begin to tell you how many more eye infections she has. Just the idea that we're able to blink and also that we can kind of physically wash away things with those secretions make a huge difference. And believe it or not, we actually do end up catching sweat dripping down a lot. Our eyebrows actually do something to kind of keep those away from our eyes, because our eyes are a more open area, just like our mouths. If you think of our openings, we all tend to have hair, and there are reasons to prevent that, to prevent sort of what's floating around from getting inside. We also have chemical barriers, and I cannot stress enough how amazing these chemical barriers are. We have pH and temperature. If you've taken micro with me or ever, you know that the conditions of bacteria especially will completely change, or viruses even will change how well a pathogen grows. We are purposely hotter than the environment, making it harder sometimes for pathogens to grow in us. We have different pHs. There's a reason our digestive system, yes, that high acidity and pH helps break down food, but it also very much helps with killing the bacteria. We also have these amazing chemicals throughout our body. And lactoferrin is kind of an awesome one. Lactoferrin will actually hold on to free iron. Iron is actually super key to all things in life. Many people have to be on iron supplements just because we need it. And we need it for our red blood cells, but even bacteria needs iron for a number of metabolic functions. So when there's free iron, fungi, bacteria, they want it. They need it. And if they're inside of us, they need to get it from us. Lactoferrin is this chemical that basically binds iron in a way that our cells can still kind of unhook it and grab it, whereas other pathogens can't. You can kind of think of this as like the child safety lock. We child safety lock up our iron so that our cells can get it and use it and stay healthy. But any pathogens or other microbes that are floating around in our body can't access that iron, and so they won't grow as well. So here are pictures. You can just see the green is fungi. When you allow it to grow normally, it grows like crazy. As soon as you as soon as these scientists added lactoferrin to the environment, the fungi could no longer hold on to the iron, and so was not able to grow as well. Lysozyme is another chemical that we make. Lysozyme will actually bind to the cell walls of pathogens. Remember, again, a cell wall is a PAMP. We don't have cell walls in our body. Our cells just have cell membranes, no cell wall inside that. Lysozyme will basically bust open the cell walls, and that will kill a lot of the pathogens, those fungi and bacteria again. We also secrete antimicrobial peptides. And we secrete these like throughout our entire body. And these are awesome. Peptides, little proteins that will, or little parts of proteins that will actually stick to cell membranes and break them open. Now, there are different antimicrobial peptides that do all sorts of different things or bind slightly differently. But the key is that we have, and I've talked a lot, and we'll talk even more about having different glycoproteins, different setups, there are just differences between what's on our cell membrane and what is on pathogen cell membranes. And so we'll stick to pathogen cell membranes and not our cells, and basically bust open the cell membrane. So we got lysozyme working on cell walls. That doesn't have to be very specific. Antimicrobial peptides, specifically binding to the characteristics of cell membranes that are not our cell membrane. And we've got lactoferrin holding on to the iron to prevent pathogen growth. The last big barriers are microbiological barriers. You can sort of think of good bacteria and good microbes and good viruses and good fungi as house sitting for us. A lot of them are doing things that are positive for us. The secretion of the staph epidermis that lives on our skin actually creates acid in a way that triggers healthier cells and prevents eczema. Long story, but it's awesome. It's a good thing. We want that bacteria there. But another thing that bacteria does is it takes up space, it takes up resources. And some bacteria even make antimicrobials. Antibiotics are natural. You know, just like, for better or worse, people can kill people, bacteria can kill other bacteria. They want to protect their area. And so we basically say, hey, you know what? You're breaking down our food. You're creating vitamins for us. You're doing something good. Sure, stay here, live here, do your thing. And while you're at it, you can help keep out the bad bacteria. And they're happy to do it. They don't need the other bacteria there. They want all the space and nutrients for themselves. So basically all parts of our body will have aspects of these mechanical, chemical, and microbiological barriers. Mechanical, again, just being physical barriers, whether that's tears coming out or saliva sort of flushing things down. We cough up phlegm, basically to get rid of some of the crap that has come in and gotten stuck. The fact that all of our cells stick together so well as having those lysozymes, those antimicrobial peptides, a whole number of things that are in our secretions and in our body in general. And then again, we are very grateful for those good microbes that are doing things well for us, or at the very least, or at least preventing the microbes and the pathogens that would be causing disease from having a nice, easy place